Hi, welcome. Now we are going to see how to solve a staff scheduling problem. I have a problem here, and we will go through the problem first, then we will also see how we can solve this problem. Okay, so what I have here is the particular company's resource need for a week. Okay, we have from Monday to Sunday, and we need this company is working for 7 days a week, so we need people for every day. Okay, each employee can work for example, this is if you consider this is warehouse, these warehouse people needs to work for 7 days a week. Okay, but actually the each employee will work for 5 days and 2 days off. Okay, so the company needs in other words, the warehouse needs 70 people on Monday, 70 people on Tuesday, Wednesday 90 people, Thursday 100 people, Friday 100, Saturday 90, and Sunday 80 people. Okay, their peak days are in the middle days from Wednesday to Friday, and Saturday and Sunday are relatively more than Monday and Tuesday. Okay, so the employee can work for 5 days week, so each employee will work, the warehouse employee can work from Monday to Friday, for example, then he will take Saturday and Sunday off. Okay, so and also we also have the wage for week. Okay, so wage per week is $40, for example, or if it is small we will make it as $400 per week per employee. Okay, this is the salary given to the employee for $400 per week. Okay, so now what we have is that we need to know how many total number of resources needed and how it can be distributed from Monday to Sunday, because a resource can work only for 5 days and 2 days it will take off. The 5 days are sequentially 5 days, continuously 5 days, then 2 days off. Okay, how can we solve this problem? Okay, because we need to know a person who takes 2 days off will be working on other 5 days, and the other people also coming on that day. Okay, so but overall we need for Monday 70 people, and this is the list given here. Okay, how can we find out how many total number of people needed to minimize the wages given to them? Okay, so to minimize the wages or minimize the salary given to them for over number of the total number of salary given to them, how can we minimize that? We can minimize that only by minimizing the number of people. Okay, so we don't want excess of people, same time we cannot have a shortage, because each day the requirement is clear there. Okay, and the same time the peak days are high and the other days are low, then we need to have people according to that. At the same time we need to minimize the salary. Okay, by minimizing the number of people. Okay, this is one of the template I have it for stop scheduling. You may have for each day the salary may be different, or instead of 5 days week it could be 6 days week or 4 days week, or continuously 4 days and 3 days off, something like that. According to your requirement you can change this problem and solve it. Use this template or this problem solving as the first step. So if you understand this one, you can proceed with more complicated or more restricted or constrained problems according to your requirement. Okay, what I am going to do is instead of we have how to distribute people from Monday to Sunday, what I am having is just changing this problem to another way. How we are going to do is then how many people start working from Monday and how many people we need start working from Tuesday, and so on. Okay, in this way what we are going to change this problem to the batch. Okay, so Monday batch, Tuesday batch. So how many people needs on Monday batch, how many people needs on Tuesday batch? Okay, so this way I just formulate the problem into a different style. Okay, so you can see here what I am having here is the batches. Okay, from batch 1 to 7. Okay, so we need to find out how many people. For example, the batch 1 is the Monday batch. Okay, if you want we can make it as this is the Monday batch. Okay, similarly this is the Tuesday batch, and so on. Okay, Monday batch is the people start working on Monday to Friday and take off on Saturday and Sunday. Similarly, Tuesday batch is the number of the people start working from Tuesday and start working from Tuesday to Saturday, 5 days, then taking off on Sunday and Monday. Okay, if that is the case, how can we formulate this one into a different table instead of this this only one dimension table to the double dimension? Okay, so what we have is the for Monday batch, what we are going to say, how many days they are going to work and how many days they are going to take leave. For example, these two are going to take leave. Okay, these two are the holidays for them. Okay, they start working on Monday to Friday, Saturday and Sunday is the holiday. So what we are going to do, we are going to code it into 1 and zeros. Okay, if they are present, okay, they are considered to be working, then it is 1. Okay, whenever they are absent it is 0. That is the off days it's 0 and working days are 1. Okay, so we are going to code this table like this: 1 and then Saturday and Sunday is the off days. Okay, then Tuesday batch people start working from Tuesday. Okay, from Tuesday to Saturday, but their off days are Sunday and Monday, correct? So this way we need to code the table. Okay, so again Wednesday people start working from here. I just copy to Sunday. Okay, but they are going to work on, they are going to have off on Monday and Tuesday. Okay, then Thursday people going to start working on from Thursday onwards to Monday, 5 days continuously. Then they are going to take off on Tuesday and Wednesday. Then Friday people start working on Friday, Saturday, Saturday and Monday, Tuesday. Then they are going to take off on Wednesday and Thursday. These two. Similarly, the Saturday people going to take off on Thursday and Friday, and Sunday people going to take on Friday and Saturday. Okay, so the Saturday people start working on Saturday, Sunday, Monday, Tuesday and Wednesday. Then Sunday people going to start working on Sunday to these 4 days. So if you see this this table, you can understand that a Monday consists of Monday batch, Thursday batch, Friday batch, Saturday batch and Sunday people. Okay, all these 5 days batch is going to come on Monday. Okay, so when you distribute people here, for example Monday 10 people, the other days are 20 people, then Thursday to Friday 480 plus this 10, 90 people going to come. Okay, but whereas the Tuesday and Wednesday people going to take off on Monday. Okay, so this one will give you the presence of the number of people. For example, if we give here some numbers for each day, what is the batch number, how many people comprise of this particular batch. For example, this is 10 people here in Monday, Tuesday it is 20 people, then Wednesday if you say like this, then again this is 40 people, this is only 10 people, again 20 people and 30 people, something like that. You want to know a particular day's number of people going to be the multiplication of the number of people in the batch and the presence of that batch. Okay, so Monday you need to include. If it is 0, then you no need to include. In other words, you can do a multiplication of these and these numbers, then you will get a particular day's number of people going to be. Okay, so 10 into 1 10, again 40 into 1 40, 10. So all this will be added. In the same time, this 20 and 30 won't be added because it is 0 when you multiply. Okay, this is the trick here. Okay, so this 1 and zeros will give you the presence and absence of that batch people. Okay, so this is the way we formulated this problem is become this problem. Okay, now what we are going to do, we are going to also see for each day what is the number of people needed. Okay, so I put it here. Okay, for each day how many number of people we need. This is the constraint actually. Okay, so for each day we have for Monday we need 70 people. Okay, Tuesday we need 70 people and so on. Okay, I put it here and you can see these cells we want to calculate. Okay, this is our objective here. Our objective is to find out for each day, each batch, how many people we need to recruit. Okay, so for each batch how many people, that means for each day how many people must start working. Okay, and this is our objective. These cells are called the changing cells here. Okay, so the problem is going to find out, you start working on these cells. These are the changing variables. Okay, so these are all the variables we are going to start putting a different numbers in the problem and find out what is the optimum value for these numbers. So the optimum values for this problem is objective. What is the objective function? So the objective function is to minimize the wages. How can we minimize the wages? Minimizing the wages. How can we minimize the wages? We must know per head the wages is $400. So we must know first what is the total number of employees we are going to recruit. Then multiply that by this 400, then you will get the per week's wage. For this week's wage we are going to minimize. Okay, so it has to be equal to total number of employees into the per head wage. How can you find the total number of employees? We are going to add this. Okay, sum of this column is going to give us the total number of employees, correct, into the wage, which is here 400. Okay, this is going to be our objective function. This is our total number of wages. This is the amount we are going to minimize by changing the variables here. In other words, we are going to change the cell value here. Here the variables, we are not putting a label to these variables. We already have a label here for each cell. B7, okay, this is B8, this is B9, and so on. You can think this one is x1, x2, x3, x4. Instead of giving them as numbers, what we are giving, we just keep the cell values, cell names, okay, which is present here. Okay, so this is if you take this one is 0. Okay, so by what our problem is going to do, it is going to put a different numbers here to minimize this value. Same time we will satisfy the every day's constraint. This is the constraint. The constraints we have for each day, how many number of people we need. Okay, this is the constraint for each day. Okay, so we need at least 70 people. We need 70 people, but we cannot say exactly 70 because problem may not be solved. Okay, but the problem may not be may not found any solution. So we need to give this one as 70 or more than 70. It could be 71, 72. Okay, so we need at least 70 people. Okay, but for each day, what is the number of people we need? It is there as a constraint. Okay, okay, again, now what we are going to do is that we need to know this is the left hand side of the constraint. Okay, so we need to know the right hand side also. So how to calculate the right hand side? Okay, before we go for, I explain how to do the constraints. This is the objective function we already finished, but this is the changing variables also we finished. Now the constraint. For the constraint, how can we formulate the constraints? Before we formulate the constraint, I want to explain to you there is a function called a sum product function. Okay, so what is sum product function? I will just explain to you because we are going to use the sum product function. We have two set of array. For example, array 1 and array 2. Okay, For example, this is value we have 1 2 3, this is 10 12 13. Okay, so we want a value of each element multiplication. For example, this element we will put it here. Okay, for this element, first element into the first element of array 2, similarly second element into the second element of array 2, similarly third element of array 1 into third element of array 2, for example. Okay, we have a corresponding element product, then we want the sum of all these values. Okay, this is our problem. We have a two set of numbers. Okay, we want to multiply these numbers and multiply, then we want to add it. Okay, if we want this one, instead of doing this way, multiply one by one and add it, what you can do is you can use the sum product function. And simply pass the array 1 comma array 2, it will give you the same result, 73. How it is doing? It will take the array 1 and array 2 as the inputs. It automatically multiply the first elements. Okay, first element of array 1 into the first element of array 2. Similarly, for the second element of array 1 and the second element of array 2, third element of array the first element of array 1, third element of array 1 and third element of array 2, it will keep this products. Finally it will add. Array is nothing but a list. Okay, so the first list and the second list corresponding elements, it will multiply and give you the sum. First it will do the products, okay, then it will do this sum. Okay, this is called sum product function. If you don't know, this is the functionality of this function. Okay, why we are doing this one? Because you see here, I'm going to find out the number of employees here. For example, now I put sample 5 6 a small numbers, some numbers here. Okay, this is the numbers. For example, I have, then how many people going to come on Monday? How can I calculate? Okay, I'm going to calculate by multiplying. I already told you 1 is a presence and 0 is absent, so the 0 ones are not going to come on that day. Okay, wherever 1 finds, those people going to come. So this day 5 into 1, automatically if you multiply these two, automatically these two will be absence. When you multiply by 0, it won't come. You multiply by 1, automatically it will be added. Okay, so we are going to, for each day, for example, I want to know how many people going to come on Monday. How can I do? I will do 5 into whether the batch is present or absence. Okay, present 1 plus, similarly 6 into the batch people on Tuesday, whether it is presence or absence, which is obviously 0 that day, so automatically it will be a 0. Okay, and similarly Wednesday batch people won't coming on Monday because they are absent, so I just multiply by this number. Okay, similarly Thursday people going to come because we are multiplying by 1 because they are present. Okay, similarly Friday people into this number. Okay, plus Saturday people into 1. Finally Sunday people into Monday. Monday, whether this number Sunday people present or not. Yes, they are present, so it is 1. So if you see, it comprises of 24 people. How it is coming? All this will be added, 10 19 plus 5 on Monday, okay, 24 people. Whereas these 10 people are, because it's absence, we are multiplied by 0, automatically it is not added to this product. Okay, here this sum product, this way, instead of doing this way, you can use sum product function, which I already explained to you, using a 2 arrays parsing. Okay, so it's easier. Okay, so what I'm going to do, instead of this 24 this way, I just change this one to sum product of, I'm going to give the number of employee array into the Monday overall present and absence array. Okay, so this is going to give you the same 24. Okay, so on Monday, how many people are present? It is going to be this. Okay, similarly we need to calculate, this is the left hand side of the constraint. We are calculating how many people are going to come based on these changing variables. Okay, changing cells. The 5 6 4 2 6 8 3 are all small numbers. I put it for sample. Okay, but the problem is going to, the solver is going to find out these numbers later. Okay, this is for example only I put it these numbers. Okay, similarly we need to calculate for Tuesday how many people are going to come. Sum product of number of employees array, comma, the Tuesday presence and absence array. Okay, similarly for Wednesday, number of employees on that day, comma, Wednesday batch, Wednesday presence and absence array. Similarly Thursday. So I'll finish it off for every day. Thursday and some product of Friday. You may have a question, why don't we drag? You can drag, but what will happen, you need to use a dollar sign for this array, because this array you no need to change, this one is keep changing. Okay, so you must be careful on relative reference. So I just type it here, some product so this is the Sunday's array. Okay, you have this one we calculated for the constraints left hand side. Okay, this is the values based on the changing values, changing variables. Okay, changing cells. So if it is I take out, everything becomes 0. Okay, this is the way we are calculating for constraints left hand side. Right hand side we already have this number, each number supposed to be greater than or equal to this number. Okay, this is given for each day. So the Monday, what we have is the constraint on, we have a Monday constraint, which is the calculated number of employees greater than or equal to RHS, which is 70. Okay, so this value is given. This is a right hand side of the constraint, this is the left hand side which we are calculating. Okay, this is the constraints on using these two we are going to put a constraint. Okay, this part is the constraint part. Okay, we finished the objective function, changing variables, and the constraints. We have one more constraint, that the employees cannot be of employee. Okay, the employee numbers cannot be 10.5, 5.5, something like that, because we have full count, so the numbers should be integers. That one is also a constraint here, we need to keep in mind, because our solution cannot give 2.2 here. Okay, so Monday batch we need 2.2 people, which cannot be accepted here. Either it is 2 or it has to be 3. Okay, either 2 or 3. Okay, something like that. So these values of these cells must be integers. Okay, that is another constraint. Now what we are going to do, we are going to solve. We set all done, and we are going to solve this problem. How can we solve it? We are going to use the solver. Okay, so where can you find the solver? You can find it here in the data. Here in the data tab there is a option analyze. There you can find the solver. Okay, because I haven't added the add-in solver into the Excel worksheet, so it is not showing the add-in. Okay, what we need to do, we are going to add the solver add-in now. Go to file, options. In the options you have add-ins. Okay, in the add-ins, the Excel add-ins, go. Then you can find solver add-in, check it, press OK. Once you added the solver add-in, you can see, go to data, you can see here solver and analyze solver. Okay, so this is the part you can bring the solver in. Then click on solver. Then you can find solver parameters window popping up. Okay, so now we are going to enter the problem here in this solver. Okay, so what is our objective function, set objective? We already set it here. You see, this is the cell. Okay, the total wages we are going to minimize, wages or salary we are going to minimize. Okay, this cell is the objective. Then what we are going to do with this cell, maximize, minimize, or value, which is the minimize, because our problem is to minimize the wages. Okay, what are our changing variable cells? Our changing variable cells are these cells. Number of employees we are going to find out. Okay, problem also going to find out these cell values while minimizing the overall wage. Okay, then finally I delete this one. Okay, finally we need to put the constraints. Okay, so our first constraint is add. I already told you all these cells must be integers. It cannot be fractional values because it's a number of employees. For that you need to select integer value. Okay, so there is here the operational box, there is int integer is there, you select that one and add this constraint. you added this constraint, you can see here it is added already. Okay, now we are going to add Monday Tuesday constraints. Monday constraint is this. Add Monday constraint. I am going to add, this is the calculated number of values employees on Monday according to the number of employees is going to come here. It's supposed to be greater than or equal to right hand side of the constraint, which is 70. So the first constraint is the left hand side is the calculated value, and right hand side is the value already we have it in the list. Okay, so it has to be the calculated value, the number of employees supposed to be greater than or equal to the given value. Okay, and add this one. Similarly for the Tuesday constraint, which is the calculated number of values employees greater than or equal to the constraint value, which is Tuesday value. We need at least 70 people, and so on. Okay, so after adding these two constraints, what we can do, we need to add for Wednesday to other things also, other days constraints also. Instead, what we can do, see, instead of adding one by one these constraints, this kind of constraints, we can add it in bulk. Okay, the solver allows because this is also a list, this is also a list, we can add it as a list. Okay, instead of adding one by one. So I delete these two constraints. Okay, I'll show you how to add in bulk, because we are going to add one by one from Monday to Sunday constraints. We add it, we just select the left hand side of all these constraints, everything in a list in a proper order, so we can select. Okay, and greater than or equal to the right hand side values. Okay, then add as a one constraint. Cancel. You can see automatically from 14 to this one, from C14 to I14. Okay, it will be matched automatically, split into different constraint. This is nothing but a 7 constraints, but we add it as a only one row. Okay, this is easier because we the Excel solver accepts as a range. Okay, it will see automatically it split into 7 constraints. Okay, so once we add it, our problem is all our variables are non-negative values. Okay, and so we need to check this one. If it is not checked before, we need to check unconstrained variables or non-negative. Then we have 3 different types of solving method: GRG, non-linear, simplex LP, and evolutionary. But ours is simplex LP. Okay, this is not evolutionary. We assume this problem as a linear problem. Okay, and see here, if it is non-linear, then we need to go for smooth and non-linear method. We need to go for GRG, non-linear engine method to be selected. If it is a LP simplex, then select simplex LP. Evolutionary engine for solver problems that are non-smooth. Okay, so our problem is linear problem. That is our assumption here. Linear, we can find a solution on linear solution here. Okay, then you also have options. You can play around this one. If you don't have a problem having a solution, or you want to make it as a different timings to search for the solution, number of iteration, what you want to work on, all these parameter settings are here. For this problem, I just leave it as a default parameter. Okay, if you have any problem, you need to go through every parameter setting, what you need to set it up. Okay, and constraint precision also you can set it. If the precision is more accurate, then it will take more time, but the precision is very high, the very low. For example, you are okay with the compromising with the precision, the problem will be running faster. Okay, so you need to go through every parameter setting here, but for time being you can use the default ones. Okay, then we set the objective, and objective to be minimized. Changing variables are these variables, these cell values, and the constraints are the variables are integers and non-negative, as well as we put every day's batch constraint already. Okay, every day's number of people constraint. Okay, now we are ready to solve. I just press OK to solve. You can see solver found a solution, and all constraints and optimally conditions are satisfied. Okay, so you want any reports, you can click on reports and press OK. It will also create you a report. This reports you can go and see what is there in the reports. It will say what is the original value, what is the value found now, and what are the constraints it used, and whether the constraints are binded constraints or not binded constraints. Okay, all these things are here in the report. And now I'm not explaining the report, you can go and see the report. So just go to the solution. You can see here the problem found a solution. Okay, it is binding, the constraints are binding. It tries to put exactly the same values. The Monday we need 70 people, it can able to allocate 70 people. Tuesday 70 people, Wednesday 90 people, and so on. So the constraints are satisfied very fine, and the number of employees is distributed here. So by minimizing the wages, which is the $48,000, okay, we need to recruit batch 1, which is the Monday batch 20 people, Tuesday batch 20 people, Wednesday batch 30 people, Thursday batch 20 people, Friday batch only 10 people, Saturday batch 10 people, and Sunday batch 10 people. Okay, so for each day you can see for this all these batches will be present on Monday, which is 50 plus 20, 70 people, whereas the Tuesday and Wednesday batch is absent. Similarly, the same way it is satisfying every day's resource constraint, resource needed. Okay, so this way you can solve and find out what number of employees needed for each batch. Okay, so this way the solver solves the problem, the stops scheduling problem, and gives you solution. Okay, and you have the problem to be different wages. You need to, if it is a different wages, you need to change the objective function, okay, according to your need. Hope this video is helpful to you to know how to solve stop scheduling problem. And if you like my videos, please subscribe to my channel. The channel button is already there in the screen itself. And God bless you.